So we're going to do a couple examples of building a polynomial function for a graph. So first thing we do is we identify the zeros, -4, 2, 0, and 3, and we use that to build the factors. So we'll call this guy f of x, and if -4 is a 0, then x plus 4 is a factor. -2 is a 0, then x plus 2 is a factor. If 0 is a 0, then x must plus or minus 0, or just x, is a factor. And if 3, then x minus 3. So we basically got the structure of our polynomial built. Now that's not going to be this unique graph. We need to pick a point that's not on the x-axis. So we have one here at 1, -15. And to find that, what I'm going to do is I'm going to put an a out front. So we need to solve for that a. So that means this function is equal to -15 when x equals 1. So we're going to plug in 1 for all our x's and see what we calculate for a. So we're going to have 5 times 4, which is 20, times 1, times a -2, so we got a -40. So a is going to be -15 over -40, which will be positive, which we can reduce a little bit down to 1/8. So the unique polynomial for this is f of x equals the 1/8 that we just found, and then times our factors. A lot of times we'll see the x written first, and then we have x plus 4, x plus 2, and x minus 3. The order of the factors doesn't matter because it's multiplication. And don't worry about multiplying these out unless you're explicitly told to. Let's do one more example that has a couple of interesting things going on that's a little bit different. So here's the graph we're going to look at. And the first thing we're going to do is take all our zeros. So we have one here at -4, we have one here at -1, and we have one here at 3. So we know how to begin to build a polynomial from that. That'll be x plus 4. That'll be x plus 1, excuse me, because we have a 0 at -1, and that'll be x minus 3. Now, contrast this with the other graph we just had. Notice at the zeros, the graph was going straight through. So we did not have to worry about any repeated roots. Now we do. We have a couple, right here goes straight through, we're not worried about it, but right here and here, we have different situations going on. Let's talk about this one first. If a function hits the x-axis and bounces off, it has what we call an even multiplicity. That means it's repeated an even number of times. That means that this factor needs to have an even exponent on it to account for that repeated root. Now, since we need to do a lot of analysis to see exactly how high of an exponent we'd need, so let's just use the lowest one. We could always adjust it later if we looked at the graph. We'll put in a square there. Now, notice what's going on at this 0. It didn't go straight through. It leveled off and then went through. When it does that, that means it's repeated an odd number of times. So that's an odd. This is an even repeat if it bounces off. So that means we need to give, this needs to be repeated an odd number of times. And again, we'll use a 3 rather than 5, 7, or 9. We'll assume the smallest, usually. We can always tell later if it's not. So far, we're doing really well. Except we need to make sure it's this unique polynomial, and we're going to find one point that's not on the x-axis. How about this point here? The point 0, 1. So what we do, like we did last time, we're going to put that a in, and that means this has to be 1 when x is 0. So 4 times 1 cubed times -3 squared. So we're going to have a times 36, or a equals 1/36. So our function g of x equals 1/36 times x plus 4 times x plus 1 cubed times x minus 3 squared. Now at this point, because we've done all this work, we should be able to check this fairly easily and just show you what I mean. Let's go ahead and plot it real quick. So we'll have the 1 divided by 36 out front, and I'm just going to put it in factored form. I'm not going to worry about multiplying this thing out. don't do that unless you're explicitly told to. Cubed, and then we have x minus 3 squared. The x didn't go in. X minus 3 squared in a standard window. Let's see how our graph looks. Pretty much spot on match for our graph because of the zeros, recognizing that two of them were repeated and whether they were even or odd, and by picking a point that's not on the x-axis.